Okay, what is a bioprocess? A bioprocess is the transformation of one chemical to another chemical under controlled conditions mediated by a biological agent. A good example of a bioprocess is wine production from grapes. And an environmental bioprocess is a bioprocess that is related to environmental quality. For example, an algal bloom is a bioprocess, and wastewater treatment plants contain bioprocesses. This talk focuses on wastewater treatment, both domestic and industrial. So, is there a problem? Yes, there is a problem. According to UN Water, most wastewater is not treated adequately, and industrial wastewater, which is approximately 20% of all water used, is also not treated, and in rapidly industrializing countries, the quantity of industrial wastewater is increasing rapidly. So, to address this problem, the goal is to design and build better environmental bioreactors. And by better, what is meant is more effective, less expensive, and contributing to the circular economy. And of course, developers are already working on this to reach this goal. So let's look at the conventional design workflow that's being followed. The reference models that are used, first laboratory studies are conducted according to defined planned experiments with many parameters to measure. Then a numeric model is made, which simply relates the data to itself, different input data to output data. And numeric models are used in many fields to predict and to design processes and machines. In the field of the environment, the reference models require the determination of many parameters, or even the assumption of many parameters. In this example, we see the chemicals in blocks, and we see the transformation processes represented by arrows. However, the existing models are difficult to use and costly to build and often inaccurate. And this situation is what motivated me to look for a better way. So the central question is, can we improve the wastewater treatment process development workflow? Workflow being the stages going from initial data collection to design. So what is unknown about the proposed workflow? Do we really need to measure so many parameters, and are rigorously designed experiments necessary? How can the machine characteristics be included in the model? By machine characteristics, I mean the dimensions, the type of materials, and the way of operating the machine. And also, would a black box approach work? A black box is simply a mapping relation between input data and response data, with no knowledge about the intermediate processes, which would greatly simplify the existing situation. So having a better model will help to design better processes. And do neural networks offer a solution? Neural networks are sometimes called black box models. As you can see, there are input data and outputs that are outside of a black box. Inside the black box is not a model of the chemical reactions, but simply the logic that is not exactly the chemical reactions. So, neural networks have the potential to be powerful tools for modeling bioprocesses, wastewater treatment bioprocesses. But after you've built a neural network, another question is, can they be used to simulate, design, and optimize wastewater treatment processes? This is the proposed design workflow that includes neural networks. First, we need to install in real industrial conditions a small mobile unit to acquire a very large data set. Then we build a neural network model. Building the model means training, validating, and saving the model. Then we explored a wide range of conditions by simulations, and we select the best parameters based on the result of simulations. So let's see an example. Step 1, install a data acquisition unit at the target site and collect data. And it's difficult to see a pattern in the raw data. Step 2, build the neural network model. So in order to compare different models, I looked at a conventional polynomial regression model and compared it to a neural network model and tested made the comparison based on predictions made with unseen data. So this is the true data in red. This is in blue dashed lines, the data made with the conventional polynomial regression model. And this is in the shaded area, we see the difference between the deviations of the prediction made by the neural network model from the true data. And we can see that in the neural network model, the deviations are less. That means that the neural network model is more accurate and is a more powerful tool for use in designing wastewater treatment processes. The neural network model is a computer code that can be saved and executed. So simulation means using the model on unseen data to make predictions. So we can define an experiment as the set of input conditions, and we can run simulated experiments while sitting at the desk. And this makes it possible to replicate a large number of experiments and to explore the entire data space and to make statistical comparisons between the results. In this case, we see 7 experiments, with the results, and we see that the results are within a narrow range indicated by the boxes and the whiskers, and we see that there's a wide separation between the different experiments. So, step 4, design and build the equipment. So, in this example, the experiments were differentiated based on the amount of product chemical produced. So, by the simulation, we determined the combination that gives the most product, and we ranked the experiments by total product formation, and then select the highest ranking experiment and build the wastewater treatment equipment according to using the parameters that were used in the experiment that gave the best result. So what are some impacts? Improvements in the design workflow could have global impacts. For example, there are 4 billion people who are not served by adequate sanitation systems today. And in the industrial wastewater market, it's a rapidly growing market. So having this type of knowledge would be a competitive advantage in reaching a market that's around 11 billion, that will soon be $11 billion. Thank you.
Thank you, Mark. Are there questions in the audience? Questions in the audience? Robbie has a question.
Is it a private industry, like across the world, is the majority of wastewater treatment private?
No.
Can you repeat the question?
The question is the majority of wastewater treatment worldwide private? The answer is no. I mean, normally a wastewater treatment plant is owned by a municipality. Sometimes it's operated by a municipality. Sometimes they hire a private company to run it. And I don't really know the proportions in the world. But in Switzerland, it's certainly public. Yeah. Okay. Other questions?
Any other questions? Are you, how much is the, I guess, environment of the bioreactor critical in that if you design a bioreactor to be installed in Switzerland, how likely it is that this same bioreactor would have the same performance, let's say, in Brazil?
I would say very low. I think that's really one of the advantages of this approach, is I'm proposing to install a small data acquisition unit and then to use that data to make a model. And I think that's the advantage, yeah.
Yes. And would you install, let's think of the same idea of comparison between Switzerland and Brazil. Would you need to install a test reactor in Switzerland and in Brazil and run this physical model in both countries to have data from these two different environments?
Yes.
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 So that would be the approach.
Yeah.
Cool. Any other questions from the audience? And nope. Mark, thank you very much.
Thank you. Thank you.